Hello, everybody. Thought I'd take a moment this evening and talk about some things going on in Russia. So we see a lot of news, and it's been going on forever once the invasion of Ukraine started about nuclear weapons are about to be launched. Nuclear weapons this, nuclear weapons that. And sometime last week, a couple days ago, Russia launched a hypersonic missile. In particular, they used one that can hit about Mach 10. It is called. I had it here somewhere. Whatever it's called. They had one that can do about Mach 10 that actually can carry is nuclear capable, and all that really means in the world is that you can put a nuclear warhead on the top of it. And a nuclear warhead weighs around 300 pounds. Okay, so when you hear those words, it's really just nuclear capable is not anything special in the world. It's really just how heavy the thing is. All right, so and I think some people are missing the point on something. So when you get these hypersonics out there, there's not really any treaties. There's not really any international agreements on them because they're kind of new. Nobody's really thought to go do that yet. And when they talk about hypersonics, what they're really talking about is a kinetic hit. And a kinetic hit is like when I shoot a bullet at somebody and they get hit, that's a kinetic hit. When you have a car accident, that's a kinetic hit. That's all it is, just two things smacking into each other really hard. Nuclear sounds scary, and it is, but usually it sounds scary because we have these big envisionments of massive bombs, and that's right. But let's look at hypersonics. So, hypersonics and most kinetic hits and any kind of thing in physics is measured in joules. So when I talk about how big these things are, I'm talking in joules. We can have a whole discussion about what that is, but let's just take it as a unit of measurement for how big something is. The bomb in Hiroshima, if you convert the sort of 15 kilotons that it was over to joules, you get about 1.5 times 10 to the 13th joules. That's 15 with 13 zeros behind it, joules, right? So it's a lot of energy took place in that bomb. Modern nukes are bigger than that. They tend to be about 100 kilotons. That's 2 times 10 to the 14th, so that add another zero. The largest one ever detonated was 50 megatons, and that's 2 times 10 to the 17th joule, so add some more zeros. And I'll have a chart in a minute, so don't worry. I'm not going to ask you to remember all these numbers. An Abrams tank, depending on the generation and configuration, if it hits you, it weighs 70 tons. We're not talking about the gun. We're talking about the tank itself. So let's say it hits you at like 30 miles an hour. It hits you with about 5.7 times 10 to the 6th joules. It's a lot of joules, right? It's more than a million. Now, let's go look at hypersonics. I happen to have made a handy dandy Excel chart to explain this problem. And I think the data speaks volumes in this case. Now, if you go converting kinetic energy over to joules, so what we have here is Mach 1, Mach 2, Mach 3, Mach 4, Mach 5, all the way through Mach 10. I listed it in miles per hour, converted it to kilometers per hour. Assuming the warhead they used was in pounds, is nuclear capable in pounds. A nuke, depending on the type of nuke, has different weights to it. Call it 300 pounds, a relatively small one. Some of them get down to about 220. Some of them get much bigger than that, but let's just call it 300 pounds. Because as we'll see in a minute, the mass doesn't matter. Because kinetic energy is actually the mass times the velocity again. So it's 1/2 the mass times the velocity squared to get to kinetic energy, or 0.5 times that column times that column twice, right? Because I'm using kilometers and I'm using kilograms instead of mass. So instead of pounds, I'm using kilograms because that's what scientists do. We use kilometers and kilograms because we want to make sense. So if you have 660 miles an hour, that's Mach 1. You convert it to kilometers, you get to 1,062. Mass 300. Mass in 300 pounds. Mass in kilograms 136. There's your kinetic energy for different Mach version or Mach numbers. So all the way through Mach 10, you get to this thing with all these freaking zeros in it, right? So that's a lot of zeros. So for comparison, I put the tank and I put the Hiroshima bomb on that same column. So here's the tank, Hiroshima. You see a problem here? A Mach 10 kinetic weapon going Mach, with a 300-pound warhead or 136-kilogram warhead does that many joules. Hiroshima did that many. Even if you add some more zeros to get to the biggest nuke ever, you get to this 2 times 10 to the 17th. This is 2 times 10 to the 21st. Even if you're only going to Mach 8, you get to 2 times 10 to the 17th. Well, 1.2, but same order of magnitude. So if you go up to 9, you get to 19, then you get to 21. So you see, everybody's yelling about nukes on the battlefront. I get it. Terrible things. But the thing that just happened a couple days ago is actually worse. Because if that really that new weapon that they displayed, they kind of shot out and said, okay, we're just going to do this. And it was a demonstration. It was just to prove they could. It's a brand new kind of intermediate range ballistic missile, but it's a hypersonic missile. It goes that fast. Now, in my career, I've worked in missile defense. I've worked on everything from Patriot to early warning systems. And I understand what it takes to knock down a missile. First thing you have to do is be able to find it, track it, and get your interceptor to it before it hits its target. No interceptor that we have in our arsenal is going to get one that's doing Mach 10. You can't detect it fast enough, shoot at it, get your interceptor. What I know, you can't get it. It's not possible. And you'd actually have to detect it first. Patriot certainly can't do it. It's too small. Standard Missile 3 can't touch it. And that was assuming you could detect that thing before it was launched and on target. So if you look at this for a minute, there's a problem. Now let's go to the chart. So if you look at this chart, up until about Mach 8, it's so close to 0, we can't really tell the difference. Then you get to Mach 9, it comes up a little bit. That's because Mach 10 is way up here. So I changed this to every time you see a line, you're actually going up by a factor of 10. This is Mach 1 way over here at 1 point. I'm sorry, what was Mach 1? Mach 1 was 76 million joules, give or take. That's over here. Now, Mach 10 is way up here at something times 10 to the 21st. You see the problem with these hypersonics? They make nukes look like day camp compared to the destructive capability. You don't have nuclear fallout. You don't have that secondary byproduct. But if you want to just absolutely lay waste to something, hypersonics are absolutely the way to do it. And do it in a way that's even bigger than the nuke. Because remember, the nuclear weapons were over here in the 13 to 14 range. So here's your nukes right in this world, right around here. So 13 to 14 is your nukes. You're now that's Mach 7, right? So Mach 7 is bigger. Here's your nuclear world. Unless you get up to the biggest nuke ever, and then you get up to the 17, that's your Mach 8 world. Mach 9, Mach 10. So you see, there happens to be very small difference in between nukes and hypersonics. And the hypersonics win that fight every single time. That's why that thing that happened in Ukraine the other day with those weird-looking reentry vehicles matters so much, because they were a hypersonic device. They hit those kinds of velocities, and I don't care if you put 300 pounds worth of worth of crushed aluminum cans in the front of that thing. 300 pounds coming down at that speed, and it's going to knock a big hole in just about anything. So that's why there's been so much military interest in hypersonics, because you can't stop them. If you're on your side, they're great, but if you're on the other side, it's not that good of a thing. So hope that clears it up for people. I saw a couple things on Twitter of people kind of talking about it, so I went through and did the math. This is really just freshman level physics math. It's kinetic energy equations. Well, like I said, is 1/2 mass velocity squared. Do the math yourself if you want. There's even calculators online where you can convert the yield of nuclear weapons over to joules. Not hard to figure out, but there you are. Kinetic weapons, absolutely bigger than nukes when it comes to destructive capability, and they do it without the radioactive waste. Going to be a short one today. Hope that helps everybody. This video stay online. I think it's going out to YouTube and Twitter or X. Sorry, Elon, I still can't call it X. But hope that clears it up for everybody. If you have questions or want to ask anything about physics, be sure to drop me a line. But that's why a lot of people, when they saw that news story, at least military folks on the strategic side, looked at that video and went, holy shit, that's actually a real problem. Because there's no treaty in the world that says you can't use kinetic weapons. Not one. Hope everybody has a good night. Have a happy Thanksgiving. We will see you on the other side of that holiday.